Hey everyone, welcome back to the channel. In this video, we are going to solve the Hey everyone, welcome back to the channel. In this video, we are going to solve the all PYQ questions of trigonometry and some important questions on trigonometry. So let's get started. In our first question, we have proved that sin theta plus cosec theta whole square plus cos theta plus secant theta whole square will be equal to 7 plus tan square theta plus cot square. Here we need to take LHS and we need to prove RHS. By taking LHS, sin theta plus cosec theta whole square plus cos theta plus secant theta whole square, and we know that it is in the form of a plus b whole square. A plus b whole square will be equal to a square plus 2ab plus b square. So converting this in the form of a plus b whole square will give us sin square theta plus cosecant square theta plus 2 sin theta into cosecant theta plus, even we need to convert this, so cot square theta plus secant square theta plus 2 cos theta secant theta. Yes, sin square theta plus cos square theta will give you 1 plus cosecant square theta plus 2 sin theta. Cosec theta can be converted to sin by 1 by sin theta plus secant square theta plus 2 cos theta, and secant can be written as 1 by cos because secant is a reciprocal of cos theta. Here cos theta cancelled, sin theta cancelled. 1 plus 2 plus 2 will give you 5. 5 plus cosecant square theta plus secant square theta. And we know that cosecant square theta can be written as 1 plus cot square theta plus secant square theta can be written as 1 plus tan square theta. And when we add 5 plus 1 plus 1, it will become 7 plus cot square theta plus tan square theta. It is equal to our RHS. Now let's move on to the second question. Under root secant square theta plus cosecant square theta will be equal to tan theta plus cot theta. Even in this question, we need to prove that LHS is equal to RHS. So by taking LHS, we need to prove RHS. So first let us, we know that secant square theta can be written as 1 plus tan square theta plus cosecant square theta can be written as 1 plus cot square theta. It is full in the square root, and 1 plus 1 will give you 2 plus tan square theta plus cot square theta. And we know that whenever if we multiply tan theta into cot theta, always gives you 1 because tan theta into cot theta is the reciprocal of tan theta. So tan theta cancel, it will give you 1. So we'll use this form in this equation, 2 into tan theta and into cot theta plus tan square theta plus cot square theta, and it is in the form of a plus b whole square. A plus b whole square. So this equation can be written as a square plus b square plus 2ab. Here a is equal to tan theta and b is equal to cot theta. Therefore tan theta plus cot theta whole square under root, square and root will cancel, so tan theta plus cot theta will be coming out. This is equal to our RHS. So let's move on to next problem. Here we have 1 plus cot theta minus cosecant theta into 1 plus tan theta plus secant theta will be equal to 2. By taking LHS, we need to prove RHS. So first let us convert all the cot theta and cosec theta, tan theta, secant theta into sin and cos. There is 1 plus cot theta can be written as cos by sin theta minus cosec can be written as 1 by sin theta. 1 plus tan theta can be written as sin theta by cos theta plus secant theta can be written as 1 by cos theta. It will be equal to 1. It will be equal to 2. So by taking LCM, here we will be getting sin theta, and here we have nothing, so it will become multiplied with sin theta plus cos theta minus 1. Here we will get, by taking LCM, cos theta plus sin theta plus 1, and here we will be taking sin theta plus cos theta as one term and minus 1 as second term. Here cos theta plus sin theta as one term and plus 1 as second term. By taking this, whenever if we multiply, sin into cos will become sin theta into cos theta. In numerator, we can see that sin theta plus cos theta minus 1, sin theta plus cos theta plus 1. It is in the form of a plus b and a minus b. So that we can write it as sin theta plus cos theta whole square minus 1 square. Therefore, it will be equal to sin square theta plus cot square theta plus 2 sin theta cos theta minus 1 divided by sin theta into cos theta. And we know that sin square theta plus cos square theta will give you 1. It is in plus 1, and here minus 1 will be cancelled out, and it will be left out with 2 sin theta into cos theta by sin theta into cos theta. Sin theta cos theta will be cancelled out. We are left with only 2, which is equal to our RHS. So now let's move on to the fourth question. Sin theta minus 2 sin cube theta whole divided by 2 cos cube theta minus cos theta will give you tan theta. By taking LHS, we need to prove RHS. So, in the numerator, we have sin theta as common. Sin theta, as we are taking sin theta as common, so 1 will be left out here, and here 2 sin square theta will be left out. Divided by, in denominator, we can take cos theta as common. So, 2 cos square theta minus 1. Sin theta as kept as it is into 1 minus, here we have sin square theta. Sin square theta in terms of cos square theta we can be written as 2 kept as is 1 minus cos square theta whole divided by cos theta into 2 cos square theta minus 1. So here sin theta by cos theta can be written as tan theta into 1 minus of 2 ones are 2 and plus 2 cos square theta divided by 2 cos square theta minus 1. This can be written as tan theta. 1 minus 2 will give you minus 1 plus 2 cos square theta divided by 2 cos square theta minus 1, and 2 cos square theta minus 1, 2 cos square theta minus 1 can be cancelled out. We will be left only with our tan theta, which is our RHS. Now let's move on to next question. Sin A by 1 plus cot A minus cos A by 1 plus tan A will give you sin A minus cos A. And here we need to take LHS and we need to prove RHS. In the LHS we have cot and tan term. Let us convert first cot and tan into sin and cos by sin A by 1 plus cos A by sin A minus cos A by 1 plus sin A by cos A. This will be equal to sin A by taking LCM in the denominator, sin A plus cos A will give you sin A plus cos A by sin A minus cos A by cos A plus sin A by cos A. And whenever we are taking reciprocal for the second term, this sin A will be going to the numerator and this cos A will be going to the numerator. Therefore, sin square A by sin A into plus cos A minus cos square A by cos A plus sin A. By taking LCM for this equation, we will be getting sin A plus cos A in the numerator, sin square A minus cos square A. In the numerator, we will be having in the form of A square minus B square. This can be written as A square minus B square can be written as A plus B into A minus B. Therefore, sin square A minus cos square A can be written as sin A plus cos A into sin A minus cos A whole divided by sin A plus cos A. Sin A plus cos A, sin A plus cos A can be cancelled out. We will be left out with sin A minus cos A, which is our RHS. And let's move on to next question. By taking LHS, we need to prove RHS, and we know that in the RHS we have tan square theta. So let us convert all the terms in the LHS to tan theta. Therefore, cot can be changed to tan theta by 1 by tan theta, that is 1 minus tan theta divided by 1 minus 1 by tan theta whole square. This can be converted to 1 minus tan theta. In the denominator, let us take LCM, that is tan theta minus 1 by tan theta whole square, and this tan theta will be going to the numerator whenever we are taking reciprocal, that is tan theta into 1 minus tan theta divided by tan theta minus 1 whole square, and in the numerator we have 1 minus tan theta, in denominator we have tan theta minus 1. So let's convert denominator in the form of numerator, that is tan theta into 1 minus tan theta divided by, now in the denominator let us take minus as common, then 1 minus tan theta whole square. 1 minus tan theta, 1 minus tan theta can be cancelled out. We are left with minus tan theta whole square. Whenever if we take negative number the whole square, it will be getting in the positive itself. Therefore, tan square theta will be coming out, it is, which is our RHS. So let's move on to next question. Cos A by 1 plus sin A plus tan A will be equal to secant A. By converting LHS, we need to change to RHS. So let us convert all the terms in the LHS to sin and cos. Therefore, cos A by 1 plus sin A plus tan can be written as sin A by cos A. When we take LCM, cos A into 1 plus sin A, and here in the first term we are having with 1 plus sin A, so we need to multiply with cos A and cos A. that is cos square A, plus in the second term in the denominator already we have cos A, so we need to multiply with 1 plus sin A, that is 1 plus sin A into sin A. Cos square A, and we need to multiply here. 1 into sin A will become sin A, plus sin A into sin A will become 1 plus sin. And here we have cos square plus sin square will give you 1, plus remaining is sin A is remaining, by cos A into 1 plus sin A. 1 plus sin A, 1 plus sin A is cancelled out, and we are left with 1 by cos A. Reciprocal of cos will become secant A, which is our RHS. So let's get started with our next question, that is sin theta by 1 minus cos theta plus cos theta by 1 minus tan theta will be equal to cos theta plus sin theta. Now by taking LHS we need to prove RHS. So let's convert all the terms in the LHS to cos and sin, that is sin theta by 1 minus cos theta by sin theta plus cos theta by 1 minus sin theta by cos theta. By taking LHS in the denominators, we are getting sin theta by sin theta minus cos theta by sin theta plus cos theta by cos theta minus sin theta by cos theta. Whenever if you are taking reciprocal to these two terms, this sign will be going to the numerator, and this cos will be going to the numerator. And whenever if you multiply sin and sin, we'll be getting sin square theta by sin theta minus cos theta, plus cos will be going to the numerator, that is cos square theta by cos theta minus sin theta. Whenever if you wanted to take LCM for these two, we need to make the denominators as common. Therefore, in the first term, we have sin theta minus cos theta, and second term we have cos theta minus sin theta. We need to convert second term in the form of first term by taking minus as common here. Therefore, sin square theta by sin theta minus cos theta plus cos square theta divided by, here we are taking minus as common. Therefore, sin theta minus cos theta, and this minus will be multiplied in this plus and it will become minus. Sin square theta by sin theta minus cos theta minus, plus into minus will become minus, cos square theta by sin theta minus cos theta. By taking LCM, we will be getting sin theta minus cos theta. Here we will be having sin square theta minus cot square theta. Numerator is in the form of a square minus b square. So we can be changed to a plus b into a minus b. That is sin theta plus cos theta into sin theta minus cos theta divided by sin theta minus cos theta. Sin theta minus cos theta, sin theta minus cos theta can be cancelled out. We are left only with sin theta plus cos theta, which is our RHS. So let's move on to the next question, that is cosecant theta minus sin theta into secant theta minus cos theta into tan theta plus cot theta will be equal to 1. Let us convert all the terms in the form of sin and cos. That is cosecant can be written as 1 by sin theta minus sin theta. Secant can be written as 1 by cos theta minus cos theta. Tan theta can be written as sin theta by cos theta plus cot theta can be written as cos theta by sin theta. Here we are taking the LCM, that is 1 minus sin theta, 1 minus sin square theta, because in the denominator we will be left out with 1. So we need to multiply it with sin theta divided by sin theta. Here 1 minus cos square theta divided by cos theta, and here we are taking LCM, that is cos theta into sin theta. Here we have already have cos theta, so we need to multiply numerator with sin theta, that is sin square theta, and here we have sin theta, so we need to multiply with cos theta, that is cos square theta. And we know that 1 minus sin square theta will be equal to cos square theta by sin theta. 1 minus cos square theta can be written as sin square theta by cos theta. Sin square theta plus cos square theta can be written as 1 by cos theta into sin theta, and 1 cos and cos will be cancelled out, 1 sin and sin will be cancelled out, and here cos theta, sin theta, and each and every term in the LHS is cancelled out, therefore 1 will be left out, which is our RHS. Now let's move on to the next question. In the 10th question, we will be having an MCQ, that is sin theta plus cos theta into tan theta plus cot theta will be equal to what? Just try this question and please comment me answer in the comment section. By proving this question, sin theta plus cos theta, tan theta can be written as sin theta by cos theta plus cot theta can be written as cos theta by sin theta, which is equal to sin theta plus cos theta into, here we are taking LCM, that is sin square theta plus cos square theta divided by cos theta into sin theta. And we know that sin square theta plus cos square theta will be equal to 1. Therefore, 1 into sin theta plus cos theta will become sin theta plus cos theta divided by cos theta into sin theta, which is equal to, here we need to split the numerator, that is sin theta by cos theta into sin theta, plus cos theta divided by cos theta into sin theta. Yes, sin will get cancelled, like cos will get cancelled. Reciprocal of cos will give you secant plus reciprocal of sin will give you cosecant. Therefore, secant A plus cosecant A is our answer. Secant theta, here they gave us angle as theta. So, secant theta plus cosecant theta is our answer. That is, option A is our correct answer. Now let's move on to next question. That is 11th question. Sin square theta minus 1 into tan square theta plus 1 equal to 0. And we know that sin square theta plus cos square theta will be equal to 1. To get sin square theta, we need to send this cos square to that side. And whenever if we are exchanging sin square theta, when I are taking this plus 1 to this minus, it will become minus 1, and this cos square will be sending that side, it will become minus cos square theta. Therefore, sin square theta minus 1 will give you minus cos square theta as formula. For sin square theta minus 1 can be written as minus cos square theta into tan square theta plus 1 will be equal to secant square theta plus 1 minus cos square theta into secant square can be written as 1 by cos square theta plus 1. Cos square theta is cancelled out and we are left with minus 1. Here plus 1. Minus 1 plus 1 can be cancelled out and here we will be lefting out with 0, which is our RHS. Now let's move on to one more MCQ, that is 1 plus sin A into 1 minus sin A will be equal to cosecant square A, sin square A, secant square A or cos square A. Please solve this question and comment me below in the comment section. For this question, we will be having A plus B into A minus B. This can be written as A plus B into A minus B can be written as A square minus B square. Therefore, 1 plus sin A into 1 minus sin A can be written as 1 square minus sin square A. 1 square can be written 1 minus sin square A. 1 minus sin square A can be written as cos square A. Therefore, option D is our correct answer. Now let's move on to next question. 1 plus tan square theta by 1 plus secant theta will be equal to secant theta. By taking LHS, we need to prove RHS, and we can say that in RHS we'll be having only secant theta. Therefore, LHS will be changed to secant theta as 1 plus tan square theta can be written as 1 plus secant square theta divided by 1 plus secant theta will be equal to, now by taking LCM, or else we can take 1 is kept as it is, and here 1 plus secant square theta is in the form of a square plus b square. A square plus b square can be written as 1 plus secant theta sorry here 1 is kept as it 1 is kept as it is. Tan square theta can be written as secant square theta minus 1, because 1 plus tan square theta will be equal to secant square theta. To get tan square theta, we need to send this 1 to that side, so secant square theta minus 1. Here we have made secant square theta plus 1, so we are getting answer as wrong. So it is correct identity is secant square theta minus 1. 1 plus secant square theta minus 1 divided by 1 plus secant theta. Here 1 plus, here a square minus b square, so it can be written as a plus b into a minus b divided by 1 plus secant theta. Secant theta plus 1, secant theta plus 1 is cancelled out. We are left with 1 plus secant theta minus 1. Minus 1 plus 1 is cancelled out. We are left with only secant theta, which is our RHS. Next, move on to next question. 1 plus sin theta whole square plus 1 minus sin theta whole square divided by 2 cos square theta will be equal to secant square plus tan square theta. And in the LHS, we have a plus b whole square and a minus b whole square. So, by taking a plus b whole square is equal to a square plus 2ab plus b square, and a minus b whole square is equal to a square minus 2ab plus b square. In the LHS, we will be getting it as, that is 1 plus sin theta whole square can be written as a plus b whole square, 1 minus sin theta whole square can be written as a minus b whole square. By taking that, we will be getting as a square 1 square plus 2 sin theta plus sin square theta plus 1 square plus sin square theta minus 2 sin theta whole divided by 2 cos square theta plus 2 sin theta minus 2 sin theta can be cancelled out. Sin square theta plus sin square theta can be written as 2 sin square theta plus 1 square plus 1 square will give you 1. 1 square plus 1 square will give you 2 divided by 2 cos square theta. The numerator we can take 2 as common, that is sin square theta plus 1 divided by 2 cos square theta. 2 is cancelled out. We are left with sin square theta plus 1 by cos square theta. And now we are going to split the numerator. that is sin square theta by cos square theta plus 1 by cos square theta. We know that sin theta by cos theta can be written as tan. Therefore, here we are having square sin square theta by cos square theta. It can be written as tan square theta plus 1 by cos square theta can be written as secant square theta, which is equal to our RHS. Secant square theta plus tan square theta. Now let's move on to the next question, that is 1 by 1 plus sin theta plus 1 by 1 minus sin theta will be equal to 2 secant square theta. And in the LHS we have 1 divided by 1 plus sin theta plus 1 divided by 1 minus sin theta. Now let us take LCM, that is 1 plus sin theta into 1 minus sin theta, and here we have 1 plus sin theta, so the numerator will be multiplied with 1 minus sin theta. Here we have 1 minus sin theta, it will be multiplied with 1 plus sin theta. In the numerator, we are having 1 minus sin theta plus 1 plus sin theta. In the denominator, we are having a plus b into a minus b. This can be written as a square minus b square, that is 1 square minus sin theta, sin square theta, minus sin theta plus sin theta can be cancelled out. 2 by 1 plus 1 is 2 by 1 minus sin square theta can be written as cos square theta, and 2 into 1 by cos square theta can be written as secant square theta, which is our RHS. Now let's move on to the next question. Under root 1 minus cos a by 1 plus cos a will be equal to sin a by 1 plus cos a. By taking LHS, we need to prove RHS. In this question, the denominator will be 1 plus cos a will be equal to, even in RHS, we need to get 1 plus cos a. To get this, we need to multiply and divide. Divide 1 plus cos a for LHS, that is 1 minus cos a by 1 plus cos a. To get the denominator of RHS same, we need to multiply with 1 plus cos a by 1 plus cos a. Numerator is in the form of a minus b into a plus b. It can be written as a square minus b square divided by, denominator it is in the form of a plus b into a plus b, that is a plus b whole square. 1 minus cos square can be written as sin square a divided by 1 plus cos A whole square. Square root can be splitted to numerator and the denominator, and the square and square roots can be cancelled out. That is sin A by 1 plus cos A, which is equal to our RHS. Let's move on to the next question, that is tan square theta by secant theta minus 1 whole square will be equal to 1 plus cos theta by 1 minus cos theta. In the LHS, we have tan square theta by secant theta minus 1 whole square. And we know that tan square theta can be written as secant square theta minus 1 divided by denominator is kept as it is. And in the numerator, we can see it is in the form a square minus b square. Therefore, it can be written as secant theta plus 1 into secant theta minus 1. It is divided by secant theta minus 1 whole square, and a square and secant theta minus 1 will be cancelled out. Therefore, we are left with secant theta plus 1 by secant theta minus 1. And we know that secant theta can be written as 1 by cos theta plus 1 divided by 1 by cos theta minus 1. When we take LCM, 1 plus cos theta divided by cos theta divided by 1 minus cos theta divided by cos theta. After taking reciprocal for this term, 1 by cos theta into cos theta by 1 minus cos theta get cancelled. Therefore, 1 plus cos theta by 1 minus cos theta will be getting. That is our RHS. Now let's move on to the next question, that is cosecant A minus sin A into secant A minus cos A into secant square A will be equal to tan A. Now in the LHS, let us convert all the terms to sin and cos, that is cosecant can be written as 1 by sin A minus sin A. Secant can be written as 1 by cos A minus cos A. Secant square can be written as 1 by cos square A. Now let us take LCM, 1 minus sin square A by sin A, 1 minus cos square A by cos A into 1 by cos square A. This can be written as 1 minus sin square A can be written as cos square A by sin A. 1 minus cos square A can be written as sin square A divided by cos A into 1 by cos square A. Cos square B can be cancelled out. 1 sin square and 1 sin A can be cancelled out. Therefore, we are left with sin by cos. So, sin A by cos A can be written as tan A, which is our RHS. Now let's move on to the next question, that is 19th question. 1 plus cot A by cos A plus 1 plus tan A by sin A will be equal to 2 times secant A plus cosecant A. This can be solved as 1 plus cot can be written as cos A by sin A divided by cos A plus 1 plus sin A by cos A divided by sin A. Sin A plus sin A plus cos A by sin A by cos A plus cos A plus sin A divided by cos A whole divided by sin A. By taking LCM now, we will be having cos A into sin A, that is sin A multiply with this will give you sin A into sin A plus cos A divided by sin A plus cos A full with multiplied with cos A plus sin A divided by cos A. Cos A, sin A will be cancelled out and we will be left with 2 times sin A and 2 times cos A, that is 2 sin A plus 2 cos A divided by cos A into sin A. Then we need to split the numerator as 2 sin A by cos A sin A plus 2 cos A can be written as divided by cos A into sin A. Sin cancel, cos cancel, will be left out with 2 by cos A. Whenever we are taking to the numerator, it can be written as secant A plus 2. 1 by sin can be written as cosecant A. Whenever if we take 2 as common, secant A plus cosecant A, which is equal to our RHS. Let's move on to our last question, that is tan theta by secant theta minus 1 plus tan theta by secant theta plus 1 will be equal to A 2 secant theta, B 2 cosecant theta, C 2 tan theta, D secant theta into tan theta. Secant theta will into tan theta, which is equal to, it is our MCQ question. This can be written as tan theta by secant theta minus 1 plus tan theta by secant theta plus 1. From this we need to take LCM, that is secant theta minus 1 into secant theta plus 1 tan theta into secant theta plus 1 plus tan theta into secant theta minus 1. In the numerator, when we in the numerator we can see that tan theta can be taken common. We are left out with secant theta plus 1 plus secant theta minus 1. In the denominator, we can take it as a minus b into a plus b. Therefore, secant square theta minus 1 and plus 1 and minus 1 can be cancelled in the numerator. We are left out with tan theta into 2 secant theta divided by secant square theta minus 1 can be written as tan square theta. 1 tan and here tan can be cancelled out. 2 into secant theta by tan theta can be changed to sin theta by cos theta. And when we take reciprocal, that is 2 into secant theta into cos theta by sin theta, and reciprocal of secant will be equal to cos. Therefore, secant and cos will be changed, cancelled out. That is 2 into cos theta by cos theta into sin theta. Sin theta, that is cos theta can be cancelled out. Therefore, 2 by sin theta we are left out. That is 2 by sin theta can be written as 2 into cosecant theta, which is our RHS. Therefore, our B option is correct. So that's it for today, guys. From the next video, in the next video, we will move on to the next still more important questions on trigonometry and even for ICSE Mathematics 2025 grade 10. From all the chapters, we'll be taking out new import all the important questions.